Hello and welcome to SIG Instrumentation presentation. I'm Marek Siarkowicz, one of the members, and today I would like to talk to you about how Kubernetes community works on instrumentation. To give a little background about myself, I'm currently working at Google, and I started contributing to Kubernetes over 2 years ago. I officially joined the SIG 9 months ago. So on the next slide, we can see the plan. So we will start from the SIG charter. We will talk a little bit about the current about the project we maintain and discuss currently ongoing efforts. At the end, I will provide you some channels when you can reach us. So on the next slide, we can see we will start from the charter. So Kubernetes is a big project with many people interested in different areas. Specific area community forms so-called special interest groups, SIGs, to have a clear boundaries and of scope. Each SIG defines their own charter. So on the next slide, you can see that our mission statement. SIG Instrumentation focuses on promoting the best practices for observability of Kubernetes. Currently, it is defined for metrics and logs, but we expect to expand this with tracing in future. As there are a lot of Kubernetes components, we need to instrument. Our work focuses on creating frameworks, libraries, and interfaces that can be used by every component. On the next slide, we defined what is in our scope, and to help other SIGs in instrumenting their features, we provide advice during whole process of designing, implementing, and code reviews to make sure that community complies to the newest guidelines in instrumentation. As a very horizontal SIG, we touch basically every component in Kubernetes. We also need to gather requirements from other SIGs, allowing us to design common APIs so they can be used by everyone. So on the next slide, we have some things that are outside of our scope. We don't process signals after they're exported by our components or build any integrations with cloud vendor specific solutions. So on the next slide, we can see our team. We are currently 19 members, and we have selected 2 chairs and 2 tech leads. Top 2 pictures belong to our chairs who focus on organization work within the SIG. On the left, we have Han Kang, and on the right, Elena Hashman. On the bottom, we have 2 TLs with focus on technical decisions. And on the left is David Ashpole, and on the right is Frederick Brańczyk. So on the next slide, we will start discussing projects, and we will discuss some projects that are actively maintained by the SIG. So on the next slide, I have a list of all projects that I want to talk about. We'll go through projects from the earliest one to the newest in how they were created. So some projects were created by us directly, and other like kube-state metrics we adopted to make sure that the community focus it's supported by the community. On the next slide, we will start from metrics API. It was the first effort within a SIG, and it allowed us to make implementation of metrics replaceable and still usable, but by auto-scaling pipelines. On the next slide, we can see that we split metrics into 3 subgroups. core metrics are metrics that are independent on the type of application that is running in Kubernetes. Those are metrics like CPU or memory. The other two types of metrics are custom and external metrics. They are different in such that they're really dependent on the type of application that is running. So, for example, requests per second for web applications or queue length by workers. Split between custom and external metrics exists because of ability of referencing Kubernetes objects. So, for example, to simplify our configuration, we can have custom metrics reference which pod they come from directly. On the next slide, we can see core metrics pipeline. To provide metrics out of the box in Kubernetes, we designed this pipeline and introduced an agent called Metrics Server. This agent will scrape metrics, core metrics from nodes and store them in memory, so they're available to be served in API. On the next slide, we can go deeper into the metrics server. So it was created as a lightweight solution that doesn't require any persistent storage or be dependent on third-party solution. Many Kubernetes distributions already deploy metrics server by default or provide an easy way to deploy it as an add-on. So on the next slide, we can see the pipeline for the two other types of metrics. Those metrics require third-party solution to provide an adapter. This adapter would translate Kubernetes API calls to a third-party native query language, allowing to expose metrics within Kubernetes to be consumed within Kubernetes. So on the next slide, we can see that also metrics server can be totally replaced, and core metrics API to be sourced from the adapter itself. So building such adapter is pretty complicated stuff. So on the next slide, we can see that a community created a custom metrics adapter. It helps third-party vendors to integrate with Kubernetes by using a ready library that contains all the necessary boilerplate. And this simplifies creating an adapter to just implementing a couple of functions in Go language. So on the next slide, we can see the other SIG project, which is KubeSig Metrics. It helps checking what is happening in the Kubernetes cluster much easier. So as an administrator, instead of running kubectl get pods every few seconds just to check if something changes, you can just deploy kubestate metrics and get those statuses as a metric and ingest them in your monitoring solution. Its main purpose is to read all the Kubernetes state of Kubernetes objects and transform them into Prometheus format. So here, for example, we can see how deployment replicas are transformed into a metric, allowing you not only to easily check if your deployment is stuck, but also alert on it. Let's now talk about ongoing efforts on the next slide. And so on the next slide, I listed three major areas that we have efforts led by SIG. I split them into three groups: monitoring, logging, and tracing. So let's start from monitoring. So on the next slide, we will discuss monitoring. So pretty early, Kubernetes adopted Prometheus as the format of internal metrics. This makes adding new metrics very easy and drove a lot of instrumentation improvements, but also led to a lot of mistakes. Over the years, the lack of guidance has led to explosion of problems with monitoring, from inconsistent metric naming, not very useful selection of latency buckets, up to security issues like caused because of memory leaks via metrics that could be forcibly created from externally. So on the next slide, we can see our effort for it, metrics overhaul. We started this effort to review all the metrics in Kubernetes and propose fixes to them to bring them in line with Prometheus guidelines. Most of the work currently is finished, but we are still finishing the final paperwork to announce the GA. So on the next slide, we can see the consequences or the problem that we encountered when working on metrics overhaul. So when we started to changing metrics, we got emails from all people whose monitoring was broken because they depended on the metrics before our change. So we need to, as part of the metrics overall effort, we needed also to define how we will handle metric changes. So we needed to define what is a breaking change and how we can notify users about them. We have decided that renaming or removing any metric or its labels is a breaking change. So if someone wants to do such a change, they would need to introduce a new version of this metric with a different name. It's simple enough, but now community need to maintain two versions of this metrics, and this can get very costly. So as there are many metrics in Kubernetes, we could not have maintained them all. So also, most metrics are not owned by SIG Instrumentation itself, but by other SIGs. We could not impose the cost of maintenance costs on others. But as metrics vary in maturity importance, we needed to inform users and ourselves what stability we and them can expect from the metrics. So on the next slide, we can see that we started another effort, which was metric stabilization. We introduced stability classes, which would give information about stability level to community. All metrics would start with alpha, and those metrics could be changed at any point without any restrictions. But after the particular metric matures enough and becomes enough that it's used by many users, SIG owning this metric can decide to make a commitment to maintain it and graduate it to stable. Stable metrics, we define a deprecation policy. The policy is very similar to what we do for Kubernetes API. It requires any change any breaking change to go through multiple versions until to maintain previous one for a couple of versions. By deciding to deprecate the metric, we automatically will notify users about this. And users will know that they should prepare for a change within a couple of versions. After deprecation in the next Kubernetes version, metric will be hidden by default, requiring user to manually re-enable it. And only after 2 versions, a metric can be a metric that was marked as deprecated can be deleted. For metrics that we created before this effort, we marked them as an alpha metric, but still we want to go through a deprecation period to allow users to adjust it to a new process. So on the next slide, we can see one of the work that we need to do. So to maintain a list of stable metrics, we created a framework that would introduce additional metadata and enforce the stability requirements. On this slide, we can see how we've wrapped Prometheus libraries and introduced additional fields with metadata such as stability level and deprecation. For users, or now users can find this information on endpoints that expose those metrics, or by checking the metadata in their monitoring solution. On the next slide, we'll discuss logging. So historically, Kubernetes logging didn't change a lot. Kubernetes uses own library. It's called Klog. It's a fork of old Google library, which is not under active development, and it didn't see any improvements to it, making its function to be really improved when we compare it to other libraries like Zap, which is currently pretty popular in Golang community. Klog has really similar logging format as printf, which makes every log line totally unique and very costly to parse and query. And so we introduced a new effort. So on the next slide, we introduced an effort of structured logging to address problems mentioned before. We wanted to migrate Kubernetes logs into new structured form, and we started it by defining new logging functions. But introducing those functions was not enough to make them useful. We need to migrate old logs, so they're useful to users. But Kubernetes it has currently around more than 10,000 log calls, and migrating those is not an easy task. And to make a new logging format useful in some reasonable time, we focused on maximizing log volume. And this allows us to keep the number of log lines to be migrated small, but still have a big impact on how logs are consumed. To make consumption of logs much easier, we also introduced a new JSON log format. So on the next slide, we can see main changes. On the top, we can see how log library invocation changed. We migrated from the printf format to a key value parse that explicitly name all the arguments. In the middle of the slide, we can see how this resulted in the different format of logs written. To maintain compatibility, we could not change the header, so we focused on changing the log message. Each argument now is named in a consistent way, allowing for creating easy tools to parse it. And on the bottom right, there is a new JSON log format, which is much easier to parse and doesn't require the backward compatibility. Structured logging just went to alpha in 1.19. Please try it and give us your feedback. So now we can go to another proposal in logging. On the next slide, we will discuss log sanitization. So last year, CNCF requested a security audit of Kubernetes. And this audit found that there is sensitive data like tokens and secrets in logs generated by Kubernetes. And because of size and complexity of the project, it was impossible to catch those things during code review. So auditors suggested we should take measures that would prevent to store this sensitive data in logs. So on the next slide, we can see the proposal that the SIG Instrumentation introduced. We want to define that data sensitivity annotations for secrets and passwords that are passed within Kubernetes code, and use them to annotate Kubernetes code base. This would allow our logging library to detect and filter this sensitive data. So that's all that I wanted to talk about logging. Now let's go into tracing. So on the next slide, I will discuss the tracing, which is so-called the third pillar of observability. So it's next to the logging and monitoring. Currently, tracing is not available for Kubernetes components, but it's very it's very useful, and its unique feature is the ability to trace how, for example, single user request or any external request interacts with any with every part of the system in a distributed system. We can, with tracing, we can find which microservices were participating when request was processed, how long the request spent in each of those microservices, and what logs were generated or metrics were changed or impacted by it, making it very useful for debugging requests. So on the next slide, we can see a proposal currently in place. It wants to introduce standard request tracing for Kubernetes API server and clients. But there is also very interesting ideas for the future. On previous KubeCon, members of the SIG presented a demo of Kubernetes object lifecycle tracing, and on this demo we could see how tracing would allow users to see all the events in cluster that are related to, for example, creation of single deployment, all the interactions that controllers take on this deployment to create pods, and then those pods having interaction with kubelets and being started by other containers on nodes. And this looks really, really interesting. I would encourage you to look into that. But because of complication on API machinery side, the first proposal was changed to focus on the standard tracing, but it opens a really interesting future for Kubernetes. And so on the next slide, I listed some channels where you can find us. So if you want to chat with us, reach us via Kubernetes Slack. If you want to write or ask a question, you can write it to our mailing list. Or if you want to talk with us directly, just talk or just join one of our bi-weekly meetings. So I think that's all. So on the next slide, thank you for your attention, and have a great KubeCon. Okay. Let's go into Q&A. There is a question from Girish. What is the difference between Kube state metrics and metric server? So the short answer is that metric server serves internal Kubernetes autoscaling pipeline. It can read metrics from either Kubernetes or external monitoring. It can read metrics from Kubernetes kubelets and expose them to autoscaling. Kube state metrics works differently in that it reads, it exposes metrics in Prometheus format, allowing your monitoring solution to use them externally. So to summarize, metric server is more for autoscaling, and Kube state metrics is more for application alerting, observability of deployments, and state of how Kubernetes workloads behave. There is also another, maybe not a question, but note from Girish about the slides. In the sketch.com site, I uploaded the PDF. Sorry for the incorrect rendering of some such slides. The PDF version should have everything working. I think that's all the questions that I have available in the system. Thank you for attending. If I can wait to, if there are any other questions, please ask them now. If not, we can conclude. There is also a question from Girish about the difference between OpenTelemetry and changes described here. So OpenTelemetry is more a system that can read different formats of metrics and transform them into like a common pipeline for transforming them into third party. So currently you could use OpenTelemetry to read metrics from Kubernetes, but Kubernetes itself doesn't use OpenTelemetry or is compliant. Kubernetes currently uses Prometheus format, so you can either use Prometheus server to collect your metrics, or any other solution like OpenTelemetry that is compatible with it to ingest this data. I think that's all the questions that I have.